Bismillahirrahmanirrahim. This is Sophia Suhailis here. So today I will explain about the surds, its definition and the operation which can be applied with the questions involving the surds. Okay, first the definition. Any irrational radical with a rational radicand is called a surd. So hence the radical this is called a surd if and only if the number inside this is a rational number, and if you're solving this one, so the result is an irrational number. Okay, so in this case if you will observe, so in the square root any prime number, it will be a surd because all the prime numbers are a rational number. In the square root all the rational numbers, they are definitely the surds. Like example, I can take more, this is a surd. I can take more example, this is a surd. But in case if you have pi in the square root 2 plus again square root of 3, so when you are solving, this number is not a rational number, so it's an irrational number when you are solving, and irrational number inside the square root will not form a surd. And inside the square root all irrational numbers, these all numbers are not a surd. So note that what in the surd, like nth power of a, this is a surd, and where n will be called as the surd index or order of the surd. Surd index or order of the surd. For example, if I will talk about cube root of 7, so here this is, here it is third order surd or surd of order 3, anything you can write. One more biggest property for the prominent property for the surd is that every surd when you are solving, it's giving an irrational number. It's giving an irrational number. Yeah, every surd is irrational number, but vice versa not true. Means every irrational number is not a surd. This is the very basic property for the surd, that every surd is surely an irrational number, but the vice versa is not true. So keep in mind this property when you are talking about the surd, or when you are taking the result of the surd, that whether they are rational or irrational or what type of the number it is. So every surd must be the irrational number when you are solving it, but every irrational number is not a surd. When we are doing addition and subtraction, like a plus b, it can be not added like a plus b under the same. When we are subtracting two surds, it cannot be written like a minus b. When we are multiplying them, so they can combine a times b inside the same power. When we are dividing this with this, so it means they can be done a divided by b under the same radical sign. Keeping these rules in the mind, let's do a few parts. Let us simplify a few examples. Okay. Solving this one, in my previous video also, I have told you whenever we have to simplify this one, we have to factorize this number in a simple way using the division method. Apply the methods in which you can see that this number, like simply I can say divisibility test. If this number have 0 in the unit column, it can be divided by 2. 2 9s are 18, 2 0 0. Still divide by 2. 45. Now 45, it's an odd number. It can directly divide by 5 also. 5 nines are, 3 threes are, 3 ones are. Now as 180 have power 1 by 2, so we will prefer to make the pairs. When we are making the pairs, 2 square, 3 square and 5 1 power will be written inside the same root. So distribute the power on all the numbers. When we distribute the power, its power will be cancelled. Its power will be cancelled. This power will not cancel, so return the radical sign as it is. 2 3s are 6 under root 5 and it is solved. What we have done, I will revise again. The number inside the radical sign, we do factorization by the simple division method. In the factor, look at the degree of the radical sign. So it's 2, so we will make the set of 2 numbers so that it can be easily free of the surd. So 2 square into 3 square into 5 and power is 1 by 2. Distribute the power on all the terms inside the bracket. When we distribute it, so the terms which have square, they will be free from the square root. This has square, it is free from the square root. It don't have square, so it will not free from the square root. So we will return this square root sign as it is. Multiply the external numbers. 2 3s are 6. Now 6 is the coefficient of this radical number. Yes, next one more example is here I am taking, in which the number, as I told you, number will be factorized with the simple division method. 96, select 2 because it's even. 2 4s are 8, 1 left, 6, 18, 16, 2 8s are 16. 2 times 4 times, 1 times 2 times, 2 6 are 12, 2 3s are 6, 3 1s are 3. As its fifth root is there, so 96, we will prefer that if possibly we can make the set of 5 numbers from here to here. So we will make the set of 5 numbers. 2 power 5 we will write, and then this 3 is a single number. From the variable x power 6, we will separate out x power 5, x power 1. From y7, we will separate out y power 5 and y power 2. z8, we will write z power 5 and z power 2 in the same fifth root. Now we will separate out these terms with the power 5. X, 2, y. All of these have fifth power. And then remaining are 3, x, y square and z 3. Combine power 1 by 5. So give power to this set of number. All of these numbers have fifth power. This set of number will not have fifth power. So distribute the power to both the terms. When we give the power to this term, it's 5 and 1 by 5 will be cancelled. So it is free from the fifth power because of the fifth root. And when we give to this term or this factor 1 by 5, it will stay as it is. So 2xy will come outside and 3xy square and z cube will stay inside in the fifth root. Like this it is simplified. Simplify, just factorize 96, make the set of 5 numbers because we have fifth root. So which number are possibly have the fifth power, make them separate, and then remaining numbers make them separate. Give fifth root to both the terms, both the set of number which we have separated out. So this fifth power and fifth root will be cancelled out and this will have still the fifth root. Now cancelling factor means after this one simplified factor will be written as it is, and then remaining all factor will still remain inside the fifth root. Like this it is completely solved. Now simplify this one. As I told you already, just do the simplification of this number, factorization of this number. This have 3. According to the divisibility test, add the digits. 3 plus 4 plus 2. 3 plus 4 7, 7 plus 2 9. As it is giving 9, so it means that this number is coming in the multiple of 3. So the whole number can be divided by 3. So 3 8s are 24, 3 1s are 3. Again 8 plus 1 9. It is coming in the multiple of 3. 3 2s are 6, 2 left, 3 7s are 21. 3 9s are 27, 3 3s are 9, 3 1s are 3. It's finished. Fifth root is there again. We will make the set of 5 numbers. 3 power 5, x power 5, y power 10, z power 15. They all have fifth root on them. As they all are multiple of 5, so we can easily distribute the power to all the terms inside. 3 power 5 give power, x power 5 with the fifth root, y power 10 with the fifth root, and in the last z power 15 with the fifth root. 3 power 1, x power 1, y power 2, and z power 3, because 5 2s are 10 and z 5 2s are 10, 5 3s are 15. So in the last we will multiply them. 3xy square z cube will be left in the last. So it is completely simplified. Let's simplify one more case. As I told you, in the radical numbers, we can combine all the number inside one radical sign. So square root, square root, square root. Under the same square root, we can combine all these terms. Like this. If we want to cancel here, we can do, because the cancellation is so simple here, 21 1 times and 3 times. In the remaining 9 by 3, we can do 3 1 times and 3 times. So the answer is under root 3. We can do simplification like this also. Yeah, how to simplify this one? Simply factorize 125 with the table of 5 and then make a set of 3 numbers, because there is a cube root on that. When it is a cube root, so make a set of 3 numbers. 4 by 5 will stay as it is. It will become 5 cube, and there is a cube root. Cube and cube root cancel with each other. This is left. 5 and 5 cancel, and the answer is 4. Like this, it is very easily simplified. One more case we have, that simplify 21 times 7 times 3. Combine under the same square root. 21 times 7 times 3. Factorize 21. 3 times 7 into 7 times 3. So this is 3 square, this is 7 square. And the square root means 1 by 2. So 1 by 2 power when given to 3 becomes simple free 3. When 1 by 2 power is given to 7 square, it will be free as 7. So 3 7s are 21 is the answer for this one. It is so easy to solve like that. Simplify these now. As I already told you that in multiplication division we can combine the terms in the same surd. We can combine the terms with the same order, but in addition and subtraction, same order addition and subtraction, we cannot combine. We cannot do like this. Okay. So the same thing will happen over here also. First we will factorize each number. Can be divided by 3. Okay. Second number 20. This is 3 square into 5 under the square root 3 times. 4 5s are 20 means 2 square and 5 plus 4 under root 5. 3 square, as it is square, so it will come out of the square root as a simple 3. This 5 will stay inside the square root. This 2 will come out of the square root and it will become 2 under root 5 plus 4 under root 5. 3 times under root 5 minus 3 2s are 6 times under root 5 plus 4 times under root 5. Now look at these terms. These terms are called like surds because the surd values are same. Under root 5, under root 5, under root 5. So what we have to do in this case, we will simply solve their coefficients like 3 minus 6 and plus 4. we will do with the same surd. Okay, means we will solve the coefficient 3 and 4 positive. 3 plus 4 7, 7 minus 6 1. 1 no need to write, so its answer will be only 5. Okay, like this it is being solved. So let's take one more example in the same way. Second part. So this is 4 under root 12 plus 5 under root 27 minus 3 under root 75 plus 300. Simplify by taking the factors. 12 is 4 threes are 4 is 2 square into 3 plus 5. 27 is 9 threes are 9 is 3 square 3 times minus 3. 75 is 15 fives are 15 is 3 times 5 into 5 5 square, or you can say 25 threes are 25 is square of 5 and 3. 300 10 threes are, and 10 is 2 square and 5 square into 3. These are the complete factors. If you cannot find out the direct factors, so do factorization by this method for every number. This 2 square number will come out of the square number square root as a free number, so multiply to the already present number. This 3 will come out of the radical sign. This 3 will stay inside. This 5 will come out of the radical sign. 3 will stay inside. 2 and 5 both will come out. This 3 will stay inside. After this, 4 2s are 8 under root 3, 5 3s are 15 under root 3, minus 3 5s are 15 under root 3, plus 2 5s are 10 under root 3. In this question specifically, these both terms are exactly same with the opposite sign, so I can cancel them. So 8 plus 10, 8 under root 3 plus 10 under root 3. How we can solve? Again, the radical numbers are same, so we can add their coefficients, like 8 plus 10 times under root 3, so it is 18 under root 3, and this will be the final answer. Okay, how algebraic identities can be applied on the question with the surd. Okay, so first I will explain, like there is a question if 3 plus this one, 3 minus this one. So the first term is 3, second term is under root 3. Okay, first term is 3, second term is under root 3. So they are matching with the identities, algebraic identities. A plus b into a minus b, it will be equal to a square minus b square. Here we can say that a is 3 and b is under root 3. So we can apply the algebraic identity like square of a minus square of b. And what is a here? 3. And what is b here? Square root of 3. So square of 3 is 9. Square root of square root of 3. Square and square root cancel. 3 will be here. 9 minus 3 6, and this is the answer for this. So in the same way I will explain one more part, that is square root of x plus square root of y, then square root of x minus square root of y, then x plus y, and then x square plus y square. After this, again first I will apply the algebraic identity on these two terms. Okay, when I apply on these two terms, so it will be a plus b, a minus b. So square of a minus square of b, in which what is a? That is square root of x. What is b? That is clearly square root of y. Remaining these terms will remain as it is until we will start solving with that. First we will simplify completely this one. Square and square root are cancelling with each other, so it will become x. Square and square root cancel, y. X plus y, then x square plus y square. Now these two terms are same, a minus b, a plus b. It means now algebraic identity can be applied on these two terms. So square of the first term minus square of the second term. What was the first term? That is x. What was the second term? That is y. Keeping close in the bracket. Now this is the last term left. We will write that as it is. This become x square, this become y square. And this term is x square plus y square. Again it is taking the form of a minus b, a plus b. Again square of a minus square of b will be applied here. What is the a term? A term this time is this, x square. And what is b term? B term is this, that is y square. So x square to square 4, y square to square, they will multiply with each other, 2 2s are 4. And like this it is solved completely. Thank you so much. In this my video, I have solved the addition, subtraction, the questions involving addition, subtraction, multiplication, and division of the surds. And I told that how you can apply the formulas and the same algebraic identities using or simplification the values in which the surd are involved. Thank you so much. Hopefully you will like my video and understand that nicely. Allah Hafiz.